Okay, welcome back. Dr. P here again. And in this lecture, we'll go ahead and take a look at something that actually isn't in the text. And that is the anti-Markovnikov addition of HBr to alkenes. So normally we've seen if we just add HBr to an alkene, we get bromine adding to the more substituted carbon, the hydrogen adding to the less substituted carbon. And this, of course, is a Markovnikov reaction. We get the Markovnikov product. That's our regiochemistry. But in the presence of peroxide, so ROOR equals some kind of peroxide. Typically, hydrogen peroxide is not used, but you could use it, I suppose. What we end up getting is the bromine adding anti-Markovnikov. We get an anti-Markovnikov addition. The bromine goes to the less substituted. And the reason for this is the mechanism. And so the fact that we have peroxides present will generate free radicals, which then will cause this reaction to proceed in the anti-Markovnikov manner. Now, I'm going to show you the mechanism, but you're not responsible for the mechanism, okay? I'm not going to ask you to do this mechanism on a quiz or an exam. All right, so let's take a look at this mechanism. You might remember from chapter 6, we write our free radical mechanisms a little bit differently. We start with an initiation step or steps. And in this case, we have our peroxide, and that OO bond there, the oxygen-oxygen bond, is fairly weak, so it tends to just kind of fall apart. So we'll go ahead and have that guy fall apart there to give us RO dot plus OR and dot. And now in the next step, we will have that peroxide or peroxy radical, well, alkoxy radical now. This will react with our HBr, and we'll get a proton abstraction. So that one electron goes and combines with one electron from there, and then another electron goes on to the bromine, giving us now ROH plus Br dot. So when I say Br dot, that means I've got that one lone electron there. And that's a neutral species. We call this type of this peroxide, we call it a free radical initiator. So that this initiates the free radical reaction. Then we have propagation. Let's go ahead and draw out this guy here. I'll put a hydrogen there. And so I'm going to have Br dot. And so I'll go ahead then and have one electron from this bond coming to make a new bond with the bromine. And then that single electron from the bromine will get a new bond. But then this breaks, of course, homolytically, and the other electron goes on to the more substituted the more substituted carbon. So I've got my bromine with all my lone pairs, and I've got my radical there. So this is now a tertiary radical intermediate. And again, this is going to form. We get this guy forming instead of having the bromine going here and getting the secondary radical. We get the tertiary radical because it's more stable. Now, the tertiary radical can go ahead then and react with another molecule of HBr. And we'll go ahead and make those fish hooks there. Boom, 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 boom. HBr, H plus Br dot. And then finally we'll have termination, which is typically just two bromine radicals that go ahead and, like that fish hook there, there we go, that go ahead and react to form Br2. Okay, now again, this is a way to stick your bromine on a different carbon in the double bond. Why would you want to do that? Well, a little later in this chapter, and then again in chapter 9, and actually going forward, we will look at synthesis. We'll look at using these reactions, stringing together several different reactions to achieve some kind of final product. So there may be cases where you would rather put your bromine on the more substituted, or cases where you want the bromine on the less substituted. And that's why it's nice to have a variety of reactions that give you Markovnikov and anti-Markovnikov products. All right, so I just wanted to show you the anti-Markovnikov addition of HBr. My understanding is it only works for HBr, not for HCl. But I wanted to show that to you because it's not really discussed in the text. Again, you don't need to know this mechanism. I just wanted to show it to understand. The key part is here, making the tertiary radical intermediate. That's the more stable radical. So we're following the extended Markovnikov rule. All right. Well, until next time, stay safe. Bye now.